Up next, a cool idea for Toronto, using lake water to replace air conditioning.
These pieces of equipment represent 1,000 tons of air conditioning. With the advent of deep lake water cooling, we've shut these off.
They don't call Toronto the big smoke for nothing. 1,000 people die every year from air pollution, and more than 5,000 are hospitalized. A good portion of the smog that plagues the city summer after summer comes from burning fossil fuels to air-condition downtown buildings. But finally, a chance to help clear the air. Deep lake water cooling, as it's called, draws cold water from the bottom of Lake Ontario to cool office towers, replacing conventional air conditioning. We visited the project just before the big pipe was submerged into the depths of Lake Ontario.
This is going to be the world's largest cooling project. There isn't a cooling project in the world that provides 62,000 tons of cooling. Over 20 million square feet of office space being cooled from one central location. That is mind-boggling.
The big benefits to the City of Toronto is that 30 to 35 megawatts of peak electricity would come off the grid.
Imagine taking 8,000 vehicles off the road of the City of Toronto. That's what deep lake water cooling will do when it displaces the coal-fired electricity generated at Lakeview. So that's a very tangible benefit.
One University Avenue, the building whose roof we're on the top of at the moment, is the first commercial building in Canada to convert to deep lake water cooling. And our slogan on that has been leading the way. Firstly, we're able to dramatically reduce the amount of electricity we use to generate air conditioning. That has advantages from an environmental perspective as well as an economic perspective for our customers.
The Deep Lake Water Cooling Project is actually two projects in one. The first part of the project involves building a brand new set of intakes for the City of Toronto's island filtration plant. On Toronto Island, there is a potable water plant that produces potable water from Lake Ontario. Two existing intakes anchor the island filtration plant, and they're approximately 100 years old.
So what they had proposed is that they will be building new intake pipes from where we're standing now out into the lake, and those intake pipes will be bringing in very cold water at around 4 degrees C. The intake pipes will actually be blended so that you have 3 pipes will go into one, and that pipe goes into the island water filtration plant.
The City of Toronto in the early 90s engaged a number of engineers, environmental groups like Pollution Probe, a whole range of consultants with energy and environmental ecological backgrounds to look at this project in as broad a way as possible, to look at all the alternative options. The concerns at the time related to would the water that was taken out of the lake to cool down the buildings change the lake when it was dumped back into the lake. It wasn't until later in the 90s, around 96, 97, that this idea came forward of using drinking water for the City of Toronto as the source of the cooling, and by using a heat exchanger, not actually using the water, but just taking the cooling out of it to make these buildings a lot more comfortable in the summer. And that then resolved the whole question of heat pollution, because you're just using the drinking water that comes in now. People use the drinking water as they use it, and it goes back through the sewage treatment plants. There'd be no net increase in the amount of heat going into the lake.
We're not taking any more water out of the lake for the Deep Lake Water Cooling Project that would normally be taken out to meet the city's drinking water supply. So this is not a project of taking water out from the lake, using it to cool a building, and then putting warm water back into the lake. It's a project where water is taken out to be used for drinking water and then used before it's given to the city for drinking to cool buildings in the downtown core.
One advantage is that the intake pipes are going further out into the lake where there is colder water, and if you get the water from a much deeper depth, then there is very little likelihood that you would end up with a taste and odor episode. So from our point of view, it's better quality water.
The potable water then makes its way across the harbor to the John Street pumping station. At the John Street pumping station, Enwave is building an expansion to the facility that will house a number of heat exchangers that will facilitate the transfer of the cold temperatures from the potable water to a closed chilled water network. That water then makes its way to the Enwave cooling plant that's located in the South Metro Convention Center, where the water is chilled and distributed to a distribution network that's located in the downtown core.
Just do some cleaning in there.
We're currently standing in what was the air conditioning room, 1 University Avenue, 265,000-foot building. These pieces of equipment represent 1,000 tons of air conditioning that were previously required to provide cool environment to the occupants of the building. They ran for approximately 16 hours a day, 5 days a week. One of the machines would run actually year-round, and they consumed significant amounts of electricity, as you might expect, given the size of the equipment. With the advent of deep lake water cooling, we've shut these off, and they no longer run, even on the hottest days.
When you generate cooling now, you use CFCs in some of the older machines or HCFCs in the newer machines. These are the chemicals that are needed to make this refrigeration process work well. Both of them, when released, do damage to the ozone layer. The CFCs, the earlier technology, much worse damage. By using deep lake water cooling, you eliminate the need for those chemicals, you eliminate the risk to the ozone layer from cooling for those buildings. And so there were two big environmental benefits.
Behind me are the 2 gold towers comprising the Royal Bank Plaza, 1.5 million square feet of office space. The air conditioning load for that building is 5,800 tons, comprises among the largest air conditioning equipment in the city, and we've recently signed a contract to shut off that equipment and convert the building to deep lake water cooling. The chillers that provide the air conditioning are 28 years old. It would be time for us to replace them. So by converting the building to deep lake water cooling, we're avoiding spending in excess of $1 million. We'll be saving money on the cost of running the equipment, and in addition to that, we'll be contributing to the environment by significantly reducing greenhouse gas emission.
What's the actual cost of retrofitting once you bring in the whole system?
The cost on that building to convert to deep lake water cooling is slightly under $200,000.
Right now, there are cooling towers on many buildings that act to cool down the refrigerant that goes through the buildings as they are. That makes downtown Toronto more humid than it would otherwise be. And this will reduce the humidity in downtown Toronto. So when you're walking around downtown Toronto in the middle of summer, it should be less humid than it has been.
A lot of people ask us the question, how does cold water air condition a space? Think of, I guess the easiest analogy would be, think of a radiator in your home. People have a boiler in the basement. They circulate hot water through a radiator and use the radiator to reject the heat into the space to warm up the air. Cooled, chilled water works in very much the same way. You're circulating chilled water through a radiator, or effectively a device known as a radiator, to transfer that cold temperature that's in the water into the air.
So we're now in the basement of 1 University Avenue, and we're standing in the room that contains the equipment that we installed to replace the chillers that we saw upstairs. This is a heat exchanger, so this is where the water that comes in from the street, from the Enwave system, is circulated through here, and the coldness is taken out of that water and fed into the building distribution system to then be circulated throughout the whole building. There are no moving parts in here. It consumes no electricity. There's very, very little maintenance associated with it. We have the opportunity to expand it should we have tenants move in that need significantly additional air conditioning. So it gives us great flexibility, and it just sits here and does its job quietly with very little attention.
Hey, Jane. The funding of this company comes from the Ontario Municipal Pension Fund primarily, and the City of Toronto as well. The The Deep Lake Water Cooling Project is a $179 million, $180 million project. The whole concept of sustainability that becomes the cornerstone of Enwave says that if it doesn't make financial sense, if it doesn't make environmental sense, and if there isn't a social benefit, you shouldn't do it because it isn't a sustainable project. Deep Lake Water Cooling meets all those thresholds. The biggest challenge that we have is making people understand what the true cost of power is. The 4.3 cent rate cap, which artificially keeps the price of electricity low and does not allow us to recover the true cost of electricity, made our product a lot more expensive for condo developers to buy. If you look out these condos, what you see are buildings that are not going to be taking Deep Lake Water Cooling. These buildings have opted for a future that is not sustainable, primarily because the government has given them no other choice. The government has said to them, if you take coal-fired electricity to power your chillers, you will only pay 4.3 cents. However, if you take Deep Lake Water Cooling or any other green energy, which is a sustainable product, you will have to pay more. And given that choice, the developers that are building that condo, the developers that will be building the condo down there, are saying, we can't afford to take this, despite the fact that we're telling them you can't afford not to take it.
For buildings in the downtown core, they have the opportunity to take advantage of an environmentally friendly technology that doesn't cost more, that does offer you the benefits to the environment, and that does free up electrical capacity.
Having come from a political background, I've always been very much opposed to handouts. And we've never gone to the government hat in hand and asking for money. What we've asked for is a level playing field. Subsidize us like you're subsidizing Lakeview. Subsidize us like you subsidize the Pickering nuclear facilities. Subsidize us like you're subsidizing the wires. And if you do that, and if you subsidize to the same tune green energy projects, not only will you get Deep Lake Water Cooling, you'll get wind farms that'll be developed, you'll get solar energy being developed, you'll get cogeneration facilities, you'll get distributed generation. You will actually begin to reduce the smog that we all breathe on a day-to-day basis.
No other alternative for cooling the downtown comes even close to the impact, the positive impacts of this option. So I would say for the environment, for downtown Toronto, it's a huge net gain.
Ideally, our goal would be to provide cooling and heating to every building in the downtown core of Toronto. That is the ultimate goal. And of course, you have to take baby steps to get there. So Deep Lake Water Cooling in the first phase envisions providing cooling to about 20 million square feet of office space. That's about the size of 20 Toronto Dominion Bank towers in the city of Toronto.
We're going to have to develop a whole new range of technologies to protect our environment. We can't continue with the old technologies. We have to go through a transition. And although I'm sure that we will come across the occasional glitch, we know that the current technology is damaging our planet in a profound way. We have to shift. And I would say that in this case, it's worth taking the risk of those glitches.